For decades, scientists believed that our early human ancestors, MPNTS, primitive hominins, only left Africa and set foot in Europe about 1.8 million years ago. This timeline was based largely on the famous evidence uncovered at the Dominici site in Georgia, where fossils and stone tools told the story of the first people to arrive on the European continent. For years, this was considered the opening chapter of human history in Europe, but a recent discovery in Romania has shaken the very foundation of that story. At an archaeological site deep within the Olteț River Valley, researchers have found evidence showing that hominins were present in Europe between 1.95 and 2 million years ago, hundreds of thousands of years earlier than science had ever known. This not only changes the timeline, it also raises an entire series of new questions about the migration routes of our ancestors. To truly grasp the significance of this find, it's important to remember that in that era, Europe's climate and environment were nothing like they are today. Vast stretches of frigid land, home to massive predators and open grasslands, stretched from east to west. For a group of hominins to survive and leave traces here so early suggests they were not mere wanderers by chance, but natural explorers, capable of overcoming extreme geographic barriers to expand their range of survival. This discovery also forces scientists to revisit a fundamental question. Was the out-of-Africa journey truly a single event following one path? Or did it happen in multiple waves, involving different groups of hominins, some of whom may have reached Europe far earlier than we had ever imagined? Africa has long been called the cradle of humankind by scientists, as it is where our earliest human ancestors first set foot on solid ground. Around 6 to 7 million years ago, primitive hominin groups began to appear here, carrying the first traits that set them apart from other primates. At first, they still resembled creatures that both climbed trees and moved along the ground. But over millions of years of evolution, they gradually adapted to the harsh environment of the savanna, developing the ability to walk upright on two legs. By about 2 million years ago, a new species had emerged, XPS, Homo erectus. Its name perfectly reflected its most distinctive feature, a fully upright posture, with free hands for making and using tools, and a brain capacity significantly larger than that of earlier ancestors. Homo erectus did not merely know how to use stone for cutting, they understood how to select the right kind of stone and shape it to create more efficient tools. These skills allowed them to exploit a wider range of food sources, from animal meat to underground roots and tubers. Many scientists believe that Homo erectus was the first hominin bold enough to leave Africa, marking the start of a new chapter in evolutionary history. 92. The journey to conquer distant lands in Asia and Europe. This migration did not happen in a single trip, but likely unfolded over thousands of generations, as small groups gradually moved step by step beyond their familiar territory. Nestled in the Olteț River Valley, in Vâlcea County of southern Romania, Valea lui Gheorghiu looks on the surface like nothing more than a peaceful countryside of open fields and dense woodlands. Yet beneath its soil lies a prehistoric treasure trove, preserving traces of both ancient humans and species that vanished millions of years ago. Archaeological work here began in the 1960s, when Romanian researchers excavated and discovered thousands of fossilized bone fragments. Most of the early finds belonged to large prehistoric animals, such as primitive deer with massive antlers, wild horses that lived in herds, and most notably, saber-toothed cats, the apex predators of their time. These discoveries quickly made the site a hotspot for paleontologists, but at the time, no one suspected it also held secrets tied to the evolutionary history of humankind. For decades, the fossils from Valea lui Gheorghiu were stored in collections, occasionally studied in research, focusing on ancient animals. It was only recently that an international team of scientists from the United States, the United Kingdom, and Romania decided to reanalyze more than 4,500 bone fragments from the area. This time, they were not only searching for information about animals, but also hunting for signs of something far more significant, evidence of hominin activity, our primitive human ancestors. By combining modern technology with cross-disciplinary expertise, the team began to identify unusual features on certain bone samples. These were not just the marks left by predators or natural forces, but precise cut marks in specific locations, patterns that nature alone could not easily produce. This discovery transformed Valea lui Gheorghiu from a moderately interesting archaeological site into one of the most important landmarks in the study of how humankind spread across the Eurasian continent. To ensure accuracy, the research team used high-resolution microscopes to examine every minute detail on the surface of the bones, details that the naked eye could barely detect. At the same time, they applied the uranium-lead dating method, an extremely precise technique when dealing with samples more than 1 million years old. This method measures the ratio of decay between uranium and lead within the mineral structure of the bone, allowing scientists to determine the fossil's age with near absolute reliability. The results were astonishing. Out of thousands of fossils, 20 samples bore unmistakable signs of hominin activity. In particular, at least 8 of those contained sharp artificial cut marks, touchènes, marks that could not be confused with bite traces from animals or damage caused by geological processes. These cuts were located at muscle attachment points on the skeleton, such as near joints or where large muscle groups were anchored, indicating deliberate defleshing to remove meat and soft tissue. This means that nearly 2 million years ago, in what is now Romania, our ancestors were not only present, but were already using tools to process animal carcasses, much as we do today. Such behavior required precise hand-eye coordination, knowledge of animal anatomy, and, most importantly, planning skills, qualities that scientists once believed only appeared in later stages of human evolution. This discovery directly challenges the long-held view that human technology and skills evolved slowly and steadily over time. In the past, many researchers assumed that early-stage hominins were still rather primitive, relying mainly on scavenging from already dead animals or using the most basic stone tools. But the evidence from Romania paints a very different picture. From the moment they first set foot in Europe, these hominins were applying intelligence to solve complex tasks. Using stone tools to strip meat from bone not only allowed them to extract the maximum nutritional value from each animal, but also demonstrated a flexible ability to adapt to their environment. In a wild Europe filled with large predators and harsh climates, knowing how to prepare and preserve meat was a survival advantage. They were no longer entirely dependent on seasonal plants or fruits. They could also exploit animal protein, a factor that likely contributed to brain development during the course of evolution. In other words, the discovery in Romania does more than simply push back the timeline of human presence in Europe. It reveals a broader story, an ancest, that from the very dawn of history, our ancestors knew how to think strategically, innovate, and cooperate in order to survive. Before the discovery at Valea lui Gheorghiu, scientists relied on a few key archaeological sites to establish the timeline for when early humans first set foot in Europe and Western Asia. Among the most notable was Barranco Leon in southern Spain, dated to about 1.5 million years ago, where archaeologists uncovered hominin teeth along with crude stone tools. Then came Kokabash in Turkey, dating to roughly 1.3 million years, famous for a partial skull believed to belong to Homo erectus. Farther northwest on the Iberian Peninsula, Cima del Elefante in Spain was dated to around 1.2 million years, with fossil traces and tools pointing to an early human presence in the region. These dates were once considered the frontier of the earliest migration into Europe. But the discovery in Romania, dated between 1.95 and 2.0 million years, has pushed that frontier back by hundreds of thousands of years. This not only makes Valea lui Gheorghiu a new landmark for Europe, but also forces researchers to ask, had hominin groups been present across Eurasia much earlier than we thought? And have we underestimated both the range and the speed of their migrations? What's especially striking is that the Romanian dates align closely with a set of findings from much farther east. In China, stone tools discovered at Shangcheng are dated to as early as 2.1 million years. In Russia, India, and Pakistan, several archaeological sites also show hominin traces dating between 2.0 and 2.6 million years. This overlap in timing suggests that the exodus from Africa did not happen as late as long assumed, but may have begun far earlier and in multiple waves. When all the data is pieced together, a new picture begins to emerge. Rather than a single wave of migration, our ancestors may have embarked on multiple journeys out of Africa, taking different routes depending on climate, food availability, and the pressures of survival. Some may have entered Europe via the Balkans, crossing its mountains and rivers. Others could have traveled through the Caucasus, along the land bridge between Western Asia and Eastern Europe. Still others might have chosen the Middle Eastern corridor, the same route later taken by Homo sapiens during their own migrations. The discovery at Valea lui Gheorghiu poses a serious challenge to the traditional out-of-Africa model, which holds that early humans left Africa relatively late, followed a single direction, and progressed in a linear manner. For many years, this scenario depicted Homo erectus migrating out of Africa around 1.8 million years ago, gradually spreading into the Middle East, and from there, moving into Europe and Asia. Instead of a single migration wave, the current evidence points to the possibility of multiple earlier migrations, undertaken by different hominin groups, each choosing their own path depending on natural conditions and survival opportunities. Some may have moved into Europe through the Balkans, crossing rugged terrain and waterways. Others may have traveled through the Caucasus, taking the route that connects Western Asia to Eastern Europe. and it is also possible that some groups used the Middle Eastern Corridor, NMIM, a route later followed by other human species, including Homo sapiens. More importantly, the discovery of defleshing behavior at Valea lui Gheorghina adds a valuable new layer to the evolutionary picture. This was not simply a matter of survival. It also serves as indirect evidence of early social organization. To hunt and process animal meat effectively, hominins needed close cooperation: hunters, lookouts, butchers, and transporters. The preparation and sharing of food also suggest the presence of community bonds, where members acted not just for personal gain, but for the survival of the entire group. Although the discoveries at Valea lui Gheorghina have opened a new chapter in the story of human evolution, they still leave many questions unanswered. The biggest question is, which hominin species was responsible for this activity? Based on the dating and historical context, many scientists lean toward the hypothesis that the makers of these cut marks were Homo erectus, DGM, the first fully upright human species to leave Africa and spread across Eurasia. However, this remains only an assumption, based on comparisons with other archaeological sites, because to date, no actual human fossils have been found directly at this location. Another mystery lies in the tools themselves. The V-shaped cut marks, made with such precision, clearly indicate they were created by a sharp-edged implement, most likely a stone tool. Yet so far, no such artifacts have been uncovered at Valea lui Gheorghina to confirm that theory. The absence of tools could be due to several factors. They may have been carried away by the river, buried deeper within unexcavated sediment layers, or simply gone unrecognized among countless naturally broken stones. For this reason, upcoming excavations will focus on expanding the search area, not only around the bone discovery site, but also within nearby sediment layers. If archaeologists can uncover stone tools, or even hominin fossils, they would serve as the missing pieces of the puzzle, helping to confirm the exact identity of these early inhabitants. If you found this story fascinating, be sure to hit like, share your thoughts in the comments, and subscribe so you don't miss the next journey of discovery. There are still countless other mysteries waiting to be told, stories that could change the way we see ourselves.